Problem, sir.
Cool. So we are continuing on with our grand tour of the Python language. And we kind of wrapped up here before the lunch break, where just, again, everything in Python is an object. Almost everything in JavaScript is an object with a giant asterisk after that, since objects in JavaScript are not like objects in Python or PHP or Ruby. But Python, really, everything really is an object. It's objects all the way down, as the saying goes. And so we can do cool stuff like very easily find if an object, or rather, if a dictionary has a certain key or stuff like that, because Python knows what kinds of object things are. And we saw that here too. And we saw that here too. And we get these great methods. And next week, we'll be looking at object-oriented programming and creating classes and defining methods. And we'll see sort of how Python builds itself. I'm just going to very quickly talk about the switch case statement here. I'm not going to write out too much code or demo it because I want to just keep the eye on the prize, so to speak. Can I get a quick thumbs up from everyone who's seen like a switch case in JavaScript? Can I maybe get like a emoji of some sort from folks who have not? Okay, so a couple people. So maybe what I will do is just copy this in and run it and very quickly talk about the behavior that's going on, because I think that that will be useful. And while I'm doing that, let me close out some of these other screens that we don't need at the moment. And it actually is good to touch on very quickly for reasons of terminology, if nothing else. Can everyone see my screen? Okay, this is a pretty good font size. Awesome. So JavaScript has something they call a switch statement. And this should look awfully familiar to what we're going to see here. Let's in fact see if like maybe, here we go. It's more nicely expressed here. The switch case, I'm not certain, but I'm almost certain these terms come from electrical engineering. And this is another way of doing conditional logic, Boolean logic, true and false type stuff. So we can use if statements to do this stuff. Sometimes what's called a switch expression works a bit better. And Python has this as well a little more recently. This is a common feature of many, many, many programming languages. Python just calls it a match statement. And so you'll note the syntax here is you say match, we say the thing that we are looking at, like this would be the thing that maybe would go inside our if statement, and we have different cases, scenarios. And if the value of this variable is JavaScript, it prints out this. So if it's this case, it's this. If it's this case, it's this, and so on and so forth. I do believe in Python, you can make the matching. I think there's a little bit of pattern matching, so it can get a little fancier here, but I'm honestly not certain about that. There are certain behaviors of switch case statements. Like I'm not sure about Python, but in JavaScript, you can have one case like fall into another, and sometimes you have to add a break statement. Really, the most important thing to know here is down here, this default, this underscore. And underscore, by the way, is what we name a variable in Python when, because of the way the language works, we need a variable there, but we don't care about it. So Python sort of knows this, and I think because this is this like undefined variable, the default behavior here must be that if whatever this is doesn't match any of this other stuff, this is our like default case. And let me in fact go ahead and run this program and let's see how we do. And of course, I need to fix my terminal environment. And of course, I apologize. It looks like we have a bit of a syntax error going on somewhere. Let's see what's going on here real quick. Match lang, syntax error, invalid syntax. So when I have my syntax wrong, the first thing I want to do is find a simple, good example. And we'll see if I can see what's going on wrong here. And if not, we'll just move on. It may be a question of version, to be honest. And actually, this article makes a good point. Prior to Python 3.10, Python did not have like match case statements. But it looks like it's correct. If anyone sees what's wrong here, please do let me know, because I am a bit surprised. The other way to debug, by the way, my favorite debugging strategy is
when
comment
I just ran it on
every.
Lang
what happened?
Just on mine it says lang is not defined. I don't know, but I don't know what's going on with this at all.
If lang is not defined, you might be missing line 1 here, where the variable set, but I'm not certain. I'm wondering. I doubt lang is like a special reserved word, but let's see what happens. Yeah, this is honestly, I think, not worth going into too much. It is for showing for debugging purposes. The two great debugging techniques are comment out everything until it works and write it again, because half the time there is some sort of syntax error where I've just been staring at the screen so long that I can't see it anymore. So often, like making the world's simplest case match, the world's simplest thing, and then trying to get that to work is a great debugging statement. So this is still wrong. So I've got something wrong with my Python syntax. I'll give it, I think, maybe
coding instead, the user input, and just to see if it's something wrong with your input.
For sure. That's a great idea. Let's do this. That would be the problem. I am not following my own advice here. Maybe it's because I tried to switch to ZSH, or I was playing around with stuff. For some reason, I'm running Python 3.8.9, version 3.8. And the match statement is a relatively new Python language feature that only exists in Python version 3.10. I'll share this link in the Zoom chat. Actually, if someone could repost it in Slack, this is a good read. And it's possible that other people may have ran into this as well. So this wasn't the plan, but this is actually a really good teaching moment about why people care about language versions and stuff like that so much. I'd have to double check. I'm pretty sure. Let's see, Python match 3.8. Yeah. So the internet confirms that really Python version 3.10 is where match came in. You can do some cool stuff with pattern matching, but honestly, part of the reason I wanted to gloss over this a bit is because 90% of the time you can use if-else statements and they work just as well. And if anything, I would say to prefer them just a bit. This match statement can be really useful for situations like this, where you have just like a long list of possibilities and the logic is pretty straightforward. But as soon as these case things starting to get more complex, or what happens for different cases get more complex, then if statements start to be more useful. So we'll do some match statements, but not a ton. You can do some very cool stuff, but it's not critical. What I do want to talk about that is more interesting and a bit deeper is these Lambda statements, because that is quite cool and touches on some important language concepts that are not like captured elsewhere. So I'm just going to kind of dive ahead and talk about that. If anyone wants to play around with the Python match, you can dig into it and see some of the pattern matching. And if you want to share like an example, you can. But again, most of the time you can use if-else statements and they'll do the same thing just as well, if not a bit better. So let me actually make a file here and we'll play around with this. So lambda functions. In JavaScript, Francisco probably showed this, some of this to all of you yesterday. There's a lot of different ways to write a function in JavaScript. I can create a function statement like this, right? And Clarice, as you were saying, we can even assign functions to variables. And I can do something like this, which is really interesting and a little funny because it means I can also like do things like this. I can be like, hello, person, plus I can pass a function as an argument in JavaScript. And I don't know, did we look at this at all yesterday? Can I get maybe an affirmative or a negative?
I don't think we looked at it yesterday, unless I'm mistaken.
Yeah, this is a bit further ahead, but this part should look familiar from yesterday, correct? Did you guys see sort of like defining a function this way? Yeah, so this is actually weirder than it seems, and I should have checked with Python as to your question, Clarice. What we're doing here is we're creating a function and assigning it to a variable. When a programming language lets you do that, it's a programming language feature called first class functions. Functions are first class. I can assign a function to a variable. And let's make sure that I have this right. If functions are treated like other variables, they're first class citizens of the language. And I did not think Python was a first class language, but I think I was wrong here. And what I want to type here, and that Google is trying to outsmart me with. That Python's functions totally are first class objects. And so we can assign them to variables as we learned. I was totally confused. And there probably are a lot of good use cases for that. More than I realized. It depends on programming style. That said, especially for this class, you'll want to get comfortable with objects and classes when we get there, and you'll see how they sort of do that same thing. But so if you think about it, once you can assign a function to a variable, there's no reason you can't pass it as an argument to another function, because that's just the same thing, right? An argument to a function is just a variable you give a function that the function does stuff with. So, I mean, I'll modify this a bit. And we'll do this and I'll go ahead and run it. And it looks like, what did I miss here? Oh, I missed, of course, I used the wrong name. Of course I did. Let's run that one more time. So to kind of, as I was encouraging in our code review this morning, to step through what's happening here, let me in fact get rid of this just for the moment so we can step through from the very beginning of what's happening when we run this program. The JavaScript engine looks at this. It says, I'm going to create a variable named say hello. What goes here? Oh, it's a function definition. All right, I got to define this function. I've done that. Now I'm assigning that function expression to this variable. And that's how we know to look it up. Then JavaScript says, hey, we're defining another function. This time the function has a name. I think JavaScript calls this a function expression or a named function expression. Let's create this one as well. And JavaScript doesn't know or doesn't care that this second argument is actually a function. When we run it, it'll figure it out, but that's part of kind of like dynamic languages like this. Like it's just kind of storing that and it's like, come back to it. We'll come back to it later. And then we hit line 10 and JavaScript says, cool, I know this function. It's got a name. All right, here are the arguments I'm going to pass it. This string and this variable. What's inside this variable? This other function. Cool. Let me call say hello with extra and pass those arguments, those variables to it. So name is Alice and hello function is a variable holding this function expression. Now we do console log hello name. And now JavaScript says, all right, this variable named hello function. It looks like it's actually a function and I'm supposed to call it. Let me travel back in time and kind of connect the dots. And oh, this comes from here, which comes from here, which is this function expression. So now I've got a function expression. Let me stick the name inside of it and run this code and print hello. And you can actually do this in a debugger, which can be kind of fun. If we put it like there and there. We don't do too much stuff with debuggers in class right now, but it is interesting to see the, I'm not going to mess around with this actually, because I actually don't use it a ton. Honestly, when I want to understand my program flow, I use console log statements, though there's a lot to be said for this. And with Python, I think we'll try to show you a bit. So that's the idea of a first class function. And that's one way that you can design a programming language. And Python and JavaScript both do this. And I want to pause and check in and see what questions people have, because I want to start with the JavaScript first before we dig into the Python. Is everyone feeling pretty good? Are we feeling a little confused? Somewhere in the middle? Cool. So we totally can do this in Python as well. I was absolutely wrong there. We can do say hello, name, and we can do like print with an F string, hello name. Then I can do say hello extra, name, other hello function. And let's just say, print hi name, and then other hello function name. And the idea is exactly the same, right? Because functions are first class in this language, I can pass them as arguments to other functions. Now, the good news here in terms of this being potentially confusing is that the sort of best practices and patterns that people follow do this in a very specific way, because this could become incredibly confusing if you're passing functions around all the time. It's very powerful because it means all of a sudden we can write incredibly flexible and dynamic programs where we can, like, as the program is running, it can pass in different functions for different things. You know, like we could have an if statement that says, like, if today is Thursday, use the say hello during the week function. If it's the weekend, pass in the say hello in the weekend function. There's a lot of interesting things that you can do. And I think this should work, but I do need to replace this with an actual value. And I also would need to be in the right directory. I'm going to be a little lazy. And do they have open? They don't have open integrated terminal. That's fine. I kind of know where I need to go. And there's my lambdas file. So now let's try this again. So that does work, which is good, because if it didn't, I would have felt a little mortified. And it's the same concept of functions are first class. Like we can define this function, and we can say var holding, func equals say hello. As Cleese was saying before, we can do this as part of a dictionary, a list, which means we can also pass it as arguments to other functions. I want to check in here if this makes sense to people, and if folks have any questions.
I have a question.
Yeah.
In your say hello extra, right? You have two parameters in there, name and other hello function. I'm just having a hard time understanding where that comes from and what that has to do with like anything.
The other hello function? Or which part?
Yes,
Or
the
other
thing? Hello function. Just that parameter, yeah.
Right. So, you can pass as many arguments as you want. Like I could have name, age, favorite, food, and so on. And these arguments, because Python is a dynamic language, I can pass a string, I can pass an integer, I can do whatever I want. Like if I wanted to, I could call my program like this and pass it a list. But this is probably going to throw an error. Well, first of all, it's expecting an argument. Well, first of all, I forgot my semicolon. Let's see how many errors. Like I could do something like this. Python won't like it, but it'll run until it throws an error.
There's a typo.
I'm surprised it got that far.
Function.
Oh, thank you so much. Which goes to show the dangers of rewriting code on the fly, and that I shouldn't ignore the squigglies, because I had that red squiggly there telling me exactly what was going on. This is not the best example, but the point being is, I can pass in whatever I want for these arguments. It's just a question of if it'll break the function or not. And so, when we write programs, we kind of depend on things being called in the right way. Like this say hello statement, someone could do say hello, like let's just say dict equals like this probably would throw an error, right? Like you can pass a dictionary into this function. Python will allow that, but then when we get here, it's going to try to do string interpolation on the dictionary and print it out, and it'll probably complain and choke and die. But we can pass in whatever arguments we want. Python doesn't know, if that makes sense. Does everyone kind of feel good about that concept? Cool. So, yes, what's up?
Oh, just when you put the dictionary there with foobar, um, I don't understand how that would interact with the function.
Yeah, no, this doesn't interact with the other stuff. I more so want to like lay a little bit of groundwork here. Like this runs, and actually I'm surprised. I guess that makes sense. Python is kind of smart about printing stuff out as strings. Like this function is not meant to have a dictionary passed into it, but it and this isn't really what we want the output to be, but it actually works. Python will let us pass whatever kind of variable we want in as an argument. So these two arguments, we can pass in whatever we want. I'm calling this function, I'm passing in a string, and I'm sending it another function. When we define this, Python doesn't know what this is. It doesn't really know what it's supposed to do here. It's only when the code is run that Python gets to this point and says, hey, it looks like this is a function that is supposed to be called. Where do I get this? And it says, oh, well, this was passed in. This is indeed a function. Like if I do this, hopefully we get an error. I think something interesting would happen. Yeah, this is perfect. So see where it says type error, string object is not callable. When we ran our code, when we called this function, Python executed this stuff, took this string, got here. It says, hey, you're doing this parentheses thing that tells me I'm supposed to call this function and pass an argument in, but you gave me a string. I can't do this. I'm going to throw an error and fail. But if instead we pass it a function, it works just fine. Does that help a little bit with your question? I'm not sure if the question was about that or more about why would we ever want to do this?
No, that clears it up. I was just confused because like I understand that it was a parameter, but then I was confused how on like line 9. It makes sense. It makes sense now. Yeah, I get it.
Awesome. Yeah, and please ask any and all questions, folks, because honestly, I'd say this is one of several sort of like fundamental computer science concepts that are kind of new. I was a little surprised people weren't asking more questions. So yeah, thank you so much, Anthony, for asking about that. As always, I kind of figure if one person has a question, there's at least 5 other people wondering the same thing. So what this is kind of leading up to is sometimes this is actually quite useful. And as you guys may have seen in JS, did we see arrow functions that look something like this? Does that ring a bell? Yeah. So, you know, and if we had more than one line, we would do this and we do this and we do like, you know, I don't know, return, hello, plus name, right? But at this point, it's a question of syntax more than the concept. So I don't know exactly the precise sort of mathematical definition for this term because it sort of does come from math. But this idea of an arrow function is really sort of a variation on something that's called a lambda function. And you'll hear these arrow functions called anonymous functions because they don't have names and they're not meant to last that long. And Python doesn't, there are differences between like with Python and JavaScript, especially with function scope. But as an example, and to kind of come back to our curriculum doc, you know, I can write a function to add stuff. to add 1 to some number if I really wanted to. Sometimes we need a function, but we don't need it to do a lot, and we want to keep it simple. A lambda is a name for an anonymous function, usually temporary, not meant to be used in tons of places. Not exactly the same as an arrow function, but sort of similar. And I wanted to talk about first class functions and show that in Python, because that's, lambda functions kind of depend on that, because this is like an arrow function. We're defining this function and we're assigning it to a variable, and then we can use it. And the syntax here is a little funny. We use this keyword lambda, and it says lambda expression assigned to a variable. This is just my linter telling me the best practice is not to use a lambda here because of reasons. But we've got our argument, function arguments, then the colon separates the function expression and the stuff that we are returning. And so in truth, this say hello stuff, instead of doing it the way I did there, it would make more sense to do it a bit like this if we were going to do it. I might want to do say hi equals lambda name f string hello name, and then what is my say hello extra? Say hello extra Bob. Say hi. Let's see. I think that should work, though. No, I think that will work. Yeah. So this is where lambdas start to become more useful, when we kind of want these little one-off functions that we want to pass around. It starts to become really useful for some operations that kind of go along with this. And I've mentioned this idea of like functional programming, and we're not going to go super deep into it, but we are going to see some bits. Like maybe I have a list of integers, and maybe I want to add, like, increase all those integers by 2. And I just did a bunch of copying and pasting here, so let me just talk about it a bit. We know what this lambda function does, right? It takes something and it adds 2 to it. If I wanted to, I could replace it with add 2, and we might in a bit. In fact, what this map function does, and we might have looked at it a little bit because JavaScript has a map function as well yesterday, but not too much, if I remember. Is that correct from what I heard people saying? So the idea of a map is, think of it in terms of like the verb, like mapping, like correlating A to B, like taking one thing and mapping it to another. We're going to go through every item in here. We're going to make a new list, go through each item in the old list, do something to it, and return it. And so we're going to build this new list with 2 added. I'll just call this, I'll just leave it as new list. And we'll just print this out just to see what it is, just for fun. And let's go ahead and run this real quick and see what this looks like. So you can see that this map returns an object. And like we sort of saw with ranges, we need to do a bit extra to like print it out or view all the things. I can do it by casting it to a list if I want. You can see that if we iterate through, we've just added 2 to each item. And in fact, I'll just cast this as a list. And this stuff, by the way, with like map and the lambdas, it's a bit more advanced. We're not doing tons of it. It is really good to see. It does come back in with a vengeance in React. So it is this really kind of core computer science concept that is kind of cool. So, right, we mapped every item in this list to an item in a new list. Right, we transformed each one. We didn't get rid of anything. We didn't add any items that weren't there, but each item got transformed. So this can be super useful for all sorts of things, such as going through, I don't know, all the users and changing their status. Sometimes you want to duplicate stuff. There's a lot of different reasons. But so this is where first class functions and these little like anonymous Lambda functions start to become really useful. And let me pause. I'm curious what questions people have.
Is the map only used with like Lambda functions?
That is a great question. I believe no. I think you can pass in any function. Yeah, looking at the definition, it just says func, which is short for function. So we could pass in any function we want. That is a great question. In fact, let's see, I've got add one right there. Let's new list equals map add one my list, and that should work just fine. Yep, and it adds one. Lambda functions get used a lot because often we care more about transforming the data than like reusing the logic. We just sort of need some logic in this one place. So it's more about convention and use, but you're absolutely right. We can pass in any function. We could pass in a function expression that we define. I could pass in this add to, right, where I've taken a lambda and assigned to it, or define the lambda inline. Josh, yes, sir.
So Python's lambda, is it, you can only do one line, right? Like it's kind of strict in that sense. Like you can't do multiple lines. Like JavaScript, you could do multiple lines within the curly.
Probably, right? I would have to look up actually like the details of the syntax of a Python lambda function, but that's probably true. At that point, you probably want to make a normal function anyway.
Sure.
Just sort of like that's sort of like a sign that if this is getting complex, then maybe at that point we want a normal function. But I'm not certain off the top of my head. That's a great question.
No
let's see,
worries. Thank
Python.
you.
Yeah. Lambda, multiple lines. We are clearly not the first person to wonder this. And the internet says, this is a much longer answer than I care about. The consensus is basically no. The consensus seems to be no, don't do that. Even if there's a way to, it's incredibly confusing. Which honestly makes a lot of sense because it makes the intent of how we are supposed to use this thing a lot clearer. Like arrow functions, you know, they are used for all sorts of things in JavaScript. It's like lambdas are really kind of specific. And let me show another awesome feature. Like these three functions, map, filter, reduce, are sort of like the bread and butter of functional programming. And they're all about, again, data through a series of tubes, moving data through functions. And this filter function, unlike map, filter gets rid of stuff from our list, but it still creates a new list. The old one is unchanged. Like if I print out my list, let me comment this out just for the moment. Note that my list is unchanged. And sometimes that's incredibly useful to still have your original data in its original form. There are other reasons why making copies over mutating can be preferred, but that is definitely one of them. So filtering does pretty much what it sounds like. And this is where lambdas start to become nice, because once you get comfortable with the syntax, you can write it. It's relatively easy to read. We do have to do this bit of casting because Python sort of wraps it in this filtered thing, I think. But now we should get our list filtered to only have things divisible by 3. And what this does really is this what the filter function does is it passes each element into this lambda function. If it returns true, it keeps it. If it returns false, it gets rid of it. Right? If it returns true, it keeps it. If it returns false, it gets rid of it. So the filter function really expects a lambda that's always going to return true or false. Map, we just need to return something. And now we've got a filtered list, plus we have our original one. And this is nice because you can see how this is like very compact, and it can be very nice to write code this way. Do folks have any questions?
I did.
Please, that's what we're here for. Yeah.
So this might be taking a step back just a little bit, but I've noticed, so for pretty much all of the methods, it seems to me like most methods won't work unless, or they won't change anything unless you add them. And when you try to print something to the terminal, and then they will work if you pass them through a function. And that's pretty much how all the methods will work. Correct?
You mean that map and filter require us to pass these functions in?
Yes.
Right, and not so much about the printing to the terminal part. I think because it sounded like there might be 2 parts there. The second part, to reiterate, we can do all sorts of interesting stuff here, like we can iterate through this new list. It's still there. It's just that the way that Python works, it sort of puts a wrapper around lists sometimes. Like if we did print type new list, let's see what that would get us. I'll come back to the other part of your question. Yeah, so because we use this map function, I guess Python has a map class. And in fact, I'm curious too, if I do this here, what we get. Yeah, and a filter class. And it's a little outside scope, but remembering that Python kind of gives us more as a language than JavaScript, and like everything is an object. Python like has it's like Python knows that this map thing can be iterated through. And under the hood, there's a list hiding somewhere. So if we cast it into a list, we can work with it in that way. So we don't always have to do that, but just for printing, it makes it easier. But for all sorts of other things we might want to do, it's very useful. To get to the other part of your question, which I think is a really good question and a good point as well, Frank, is you are absolutely correct. we are now venturing into the territory of using code written by other people, right? Like we're looking at more complex language features. Soon we'll be using libraries written by other people. And because Python is a dynamic language where it won't stop us from using stuff in the wrong way, because you can make a variable anything, it becomes more and more important to read the documentation and understand how these things are supposed to be used. You know, it's like you could use a flathead screwdriver to turn a Phillips screw if you had to, right? You can like squeeze it in there to get the flat one to work with the one with the cross. That's not really how they're meant to be used. And so you're absolutely right that more and more what we'll see is that it's about understanding how these things are meant to be used and using them in that fashion. And these tools, these classes, these functions, map, filter, they expect and require us to pass some function as their first argument, because that's what they use to do their work. Like map's job is just to do something to every item in a list. It doesn't, and then give us a new list. It doesn't know what it's going to do. And that's kind of the power of it. And the power of first class functions is that it becomes incredibly flexible. But then we do have to like pass it that lambda. And same with filter. It's great that filter does a lot of that work for us, because we're going to want to filter stuff all the time. But we have to tell filter, how do I know if I should keep this thing in the list or get rid of it? And that's where a lambda function, an anonymous function, being able to pass a first class function as a variable is so helpful, because we can say filter, here's your function, give it every item in the list as an argument. If it returns true, keep it. If it returns false, throw it out. Does that help a bit?
Yes.
Awesome. Yeah, great question. What other questions do people have? Cool. So there's a little bit more I want to get through, and then we'll take a break. And then we'll look at test-driven development in Python. And I know this has been a long day, and I do apologize. I think it's just good for us to get through this stuff. I'm gonna skip this other method here, sort. It works the same way with the lambda. I'm going to skip over that because I think it's relatively straightforward now that we're starting to see this, to get a sense of what it does, right? It sorts the list. And we kind of give it a function that tells it if something should go up or down. And there's a little bit of syntax here to get, but the concept is pretty clear. This function reduce is a little more novel and something probably that many of us have not seen. And for this, I think we do actually have to import part of the standard Python library called functools, which is short for functional tools, as in functional programming tools. And let me just quickly rename this so that we don't get confused. And now let's talk about reduce. This is an interesting one. We have a list. We have a lambda. We have this word ag that sounds sort of like egg, but it's short for aggregator. So what reduce does, like map, like filter, it goes through every item in a list, but unlike them, it does not return a new list. It returns, well, we can tell it like to return, I think, like a list or a dictionary, but it bundles stuff up. Like if we look at this lambda function, it takes two arguments. The first one is called aggregator. The second one is called item. And what is it doing? It's adding them together. And let me break this out real quick and we can see it in action. Just to help us break this down piece by piece. did we not like? Add two things is not callable. I sure thought it was. Maybe it's that period. There, yeah, that comma at the end there. Okay, so I've got a lot of print statements here. Let me see if I can't get rid of a couple of them real quick. Let's see if this isn't a little easier to read now. There we go, much simpler. So a lambda function that takes two arguments. We'll talk about why aggregator is called aggregator in a minute. Takes two things, it adds them together, right? Print, add two things, 1, 4, we get 5. What reduce does is this aggregator, right? To aggregate means to bundle everything up, to put it all together, to combine it. What reduce is doing with this lambda function is going through each element, it adds it to this aggregator, which starts out probably with a value of 0, and then keeps on adding. So it adds 1 and 2, which is 3. And so reduce takes the output of this and passes it in as an argument. So 1 and 2 added together to make 3, passed in as the aggregator. 3 is added to that to make 6. 6 passed in, 7 added, and so on and so on and so on. And it looks like that. And someone was talking about like stringing together words and like combining it all. And so like you could also think about it like this. Let's see if I got that right. I almost got it right. I clearly got a part of it wrong. And that would be because this needs to be in those curly brackets. Right, so what does this lambda function do? It takes two strings and puts them together with a space in the middle. What does reduce do? It goes through each item in a list. It runs each item through the lambda, passing in the aggregator, takes whatever that returns and passes that in as the value for our aggregator for the next run. Combine hello and world, and we get hello world. Next run, hello world passed in as the aggregator, and it passes in its. Hello world, its. Last one, hello world, its, and then sunny, excuse me. So reduce is really cool. It does take a little while to wrap your head around. Again, don't stress out too much. We don't use these a ton. It does pop up more with React.js, but they are really cool and powerful things to know about. So I want to pause here and see what questions people have. Brian, yes, sir.
So the func tools, you imported something onto your machine. Would you show us how to do that, please?
Absolutely. Great news is this one's really easy. We're actually going to talk about modules in a minute. Let me actually just do that right now, in fact. So as programs get bigger, the challenge becomes organizing stuff. And you guys have probably heard the term scope and namespace tossed around a little bit. And the idea here is, let me close out some of these files so that my world is a little easier. Let's say I've got 2 Python files, right? Soon we'll be writing programs with lots of Python files. Real world programs have dozens to hundreds of files or more. Sometimes there's 10 lines in a file. Sometimes there's hundreds of lines in a file. There's all sorts of systems and rules and best practices around what goes in what file. My Python program is running, and one file I've created a variable named myvar, and it's set to 5. In the other file, a variable with the same name, also myvar, set to, well, 7 here and 5 here, excuse me. Somewhere else in my Python program, we're going to run everything in both these files. How on earth does Python know which version of myvar to use? Or how do we avoid one of these overwriting the other? In JavaScript, they actually can overwrite the other. So this is where the idea of, you'll hear it called scope or namespace. I couldn't define the difference between those two terms strictly if I had to. They are similar and used interchangeably, though there is a difference. But the important concept here with namespacing that we're going to talk about for today is we have to have some way to divide up our world so I can use the name myvar in some part of my program and use it again in somewhere else and keep it separate, right? Like I can have 2 different apartment buildings that both have apartment 1. If throughout the entire universe there was only, no way to tell the difference between apartment 1 in my apartment and your apartment, that would be really tough. So we need containers. And everything in programming comes down to names, as we saw with first class functions and passing stuff around. The Python runtime, the JavaScript runtime, all these programming language runtimes, when they read our source code, they're building up giant lists of names and keeping track of stuff. And that's how they know where to find things. So there's the idea of a namespace. And there's all different ways of doing it. You've sort of seen it in practice with things like functions, and other places with scope where, you can define a variable inside here, but it's not going to be universal everywhere. Like, JavaScript's for var I, like the I lives inside the for loop. A common term that you'll hear is modules. I need a way to be able to chunk up my code and give it a common namespace and then grab it from different parts of my program. Modules don't have to be the same as files. It can depend. In Python, a file is a module. And I'm probably getting the syntax wrong here. And in fact, let's just Google it to make sure I get it right. From import, so I think I had it right. Let's try it again. From file 1, import, hello. I might need a py after it. Let's see. Let me make sure everything's in the right spot. Everything's in the right spot. Let's see what we're complaining about. No name, hello, in module file 1. Should be a name hello. So I've almost got this right, but there's something I'm doing wrong here. So give me just a moment to correct myself, or if someone already knows, please just let me know, because I'm just having a brain fart at the moment.
I think when you're importing, you have to put the file address, right? Like slash or dot slash.
Oh, of course. Actually just dots, I think.
What if you just do actually never mind. I was gonna wonder if you could just import without like the from, since it's your file. Can't you sometimes just say like import or something, like a shorter version, I thought?
You can, I'm gonna kind of look at that in a sec. I mean, we could import the whole thing. Maybe I should start with that. In fact, the dot slash, that does seem to make it a lot happier. Relative imports cannot be used with the import a form, blah, 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 blah. Let me just do a quick Google to get my syntax right. So I literally am just Googling Python import from file because I'm like 90% here. And as you all can see, there's just so much stuff to keep track of that it kind of just goes in one ear and out the other. But
You
this
can do
is,
like import star from file, and it would just
yeah,
import
that there's
everything.
a whole, yeah. Yeah, the import star is a whole other thing. Maybe this is, I think this is, yeah, no, this is actually working just fine. Now I think this is working just fine. Let's try running this and see if it works. So these squigglies are just, that first squiggly is complaining because my var was unused. And it's still complaining because it says it should be a constant. This squiggly is complaining about, it wants me to put a comment in there, and the unused file one is a little different. And let's do this. So in fact, we can just comment this stuff out. We can just get rid of it for the moment, in fact. And thank you all for being patient with me here. And I apologize that it took me a minute to get my bearings. There we go. So I was talking about files and modules and then totally got wrapped up on syntax. This is a great example, by the way, of why pair programming can be great, so that one person deals with that and the other person is just like, import the file. What Python does is every file is a module. Every module has its own namespace. Under the hood, it probably is creating, like, I think there's a module class. And so we've got an object with this property that's a method, and we'll see this next week. But so I don't have to like type export or anything like that. In fact, I can also do print file one, my var. And in fact, let's put this other my var here, and we'll just do print that too, because that actually is a good illustration. So this is great. In file two, which is its own Python module, I define a variable named myvar. I print it, it's 5. In fact, even better, let's print it here after we have imported the other one, just to prove that nothing's getting overridden. And it isn't, it's still there. We import this other module, which is just a file. It's in the same directory. You guys are absolutely correct. If I had put this like somewhere else, if it was a directory up, I might have to do that. If it was in another file, it might have to be in like, I don't know, something like my functions, whatever the directory name is, I do need the path to where that file lives. But when I import it, then from Python's perspective, it's a module. And it's like this object. It has these properties that we can call. Methods, variables. And because these belong to this, they're scoped like inside of that name, and we don't get name conflicts. The other way to do this, I will just do this. And we'll make another one. And we'll put it over there. Is, let's just say goodbye. What I was trying to do before, and what I think will work just fine now that I've got it in my world sorted out, is from file 3, import, say goodbye. And now here, I should be able to do say goodbye. And this should work fine. Wrong command, excuse me. So this is nice because our imports are more specific. If I have like 100 functions in here, it can be nice to know which ones are getting used. Your editor can get really smart about that. It saves a bit of work. I don't have to do file one dot, module name dot this dot that and so on. In general, I would say prefer this way of importing when you can, but it's not the end of the world. As someone mentioned, like if you do, I'm not sure if import star works in Python, it might. It's probably best avoided if it does, to be honest. What we can also do is just for funsies, let's do touch file 4.py. And let's do in file 4, my var equals hello world. Now, let's say I want to make life simple and not have to like do file 1 for everything, but my var already exists. From file 4, import my var as file for my, let's just call it other var. Because if I didn't do this, one of these my vars would overwrite the other because they have the same name. But we can use aliases when we import stuff to give different names to avoid name conflicts. So let me just pause there. I'm curious what questions people have.
I was wondering, are the modules in JavaScript pretty much the same thing as the modules in Python?
Yeah, that is a great question. The general concept is the same. We want to be able to like have namespacing and basically have a file have its own namespace. JavaScript is, while awesome, a bit of a hot mess. It used to have 0 concepts of modules at all. It then had one version of modules that works a kind of different, and then it has another version of modules that works better, but has some quirks and you use it differently. So we're going to look at that when we get closer to React, because there are like some funky specifics with that. But and yeah, that's the short version. There's funky specifics because everything with JavaScript is sort of like, I don't know how many of you know this story, but this guy, Brandon Ike, I think at Netscape in the 90s, wrote JavaScript in like 2 weeks. And no one thought it would become the most popular programming language in the world and that the web would become what it was. So ever since then, everyone, he did a pretty good job for doing it in 2 weeks. But ever since then, everyone's been trying to like, put duct tape and like shoestring around this language that was never meant to do all these things. And just to kind of close the loop on this, because the original question was about, let's see here, about import func tools. So we now know what a module is, and we've seen it. It's just a file, can import other files. So you could have, like, we could have func tools py, and it could import from other files, and it often makes sense to do that. So you've just got the one thing. But the good news is that, like, when you install the Python programming language, it's got what's called a standard library. And a library is just sort of a fancy word for a bunch of modules that someone else wrote that are all sort of meant to be used together. And so this one is already installed, and I don't need to tell Python where to find it because it comes with Python, if that makes sense. Great question. The Python virtual environments, when we start installing stuff like Django or using pip, the Python package manager, to download modules or packages or frameworks, you know, which are all sort of terms encompassing the same idea, like framework, library, collection of module, package, a module that you can get over the internet with a package manager. Then, you know, we kind of use the Python environment to help Python know where to find stuff. But that's the basic idea. I think the last bit to mention is, speaking of modules and paths and files, it is worth briefly mentioning how to interact with the file system in Python, because that is something that we often will have to do. And I am really sorry, folks. I know how long today has gone on, and there's an awful lot more that we want to cover. I may chat with Francisco to figure out what makes the most sense, because we're almost done. I did skip over a couple things. I think I can squeeze in reading and writing files. We have a whole sort of chat about test-driven development I really would like to show, because we use it. But regardless, we'll wrap this up and then we'll take a break. And this stuff is really useful to know. So JavaScript has this with Node.js too, a module called OS for operating system. And this comes from the Python standard library as well, because basically we want our programs to be able to talk to our file system and do stuff. This should get the current working directory, the directory that this code is being executed in. Actually, let's just do CWD. And let's play with this real quick. And note that we get an absolute path by default. I'm sure there's an argument we can pass to tell this method that to give us a relative path, but by default, it gives us an absolute path. Interestingly, the real question is, now if I navigate somewhere else, so now I'm in my Code Platoon curriculum directory, I can, you know, pass the path to where this file is, Victor's demo and notes, in the JS Python intro, day 4, and the file is paths. We can run it there. So no, it's not giving me the directory the file lives in. It's giving me the directory I'm executing my program from. The file lives here. I'm running the Python program from over here. So when this code is run, I don't know exactly what this does, but it's a pretty decent guess. And you can imagine when the code is run, it is literally doing this and returning that. And we run this, it gives us where the command was executed from. So that's something that's good to think about, that where our file lives is not always the same directory where we execute our program. That said, for simplicity and for learning purposes, almost all the programs you'll be writing over the next week to 2, you can just run your code from the same directory where the file is, and that will make your life easier. So I want to check in and see if folks have any questions. There are a bunch of other methods that this OS module gives you. And it can be super useful, but really the path is the big one, sort of the killer feature, as they say. So that's a good one to know. Last bit I want to point out is, let's do reading and writing files. Because this is also a good one, and this is where we will want to use this.
Adam, in your last open file, the paths py, what directory was printed to the console?
You mean, with this command right here?
Yeah.
Yeah. So when I run this program, and I actually should probably move reading and writing files into Victor 1, because that is where all our stuff lives. So when I run this command, when I say Python, execute the source code in this file, the Python program executes that in whatever directory in the shell I'm running that command from, right? The current directory that I'm in. I don't have to run this command from the same directory that my file is in. I can never, and there are all sorts of reasons why you might want to do that. Right, that pass py file is inside that for-python-pytest intro directory. So maybe because I'm doing other work over here, I want to do it like this. I pass the path to the file. This is a relative path. And whenever I run this program, this get current working directory prints the working directory is wherever the program is executed, wherever this command happens.
Thank you.
Yeah, great question. And again, for simplicity, I recommend as often as you can, just be running your code in the same directory where you're creating the files. Eventually with bigger projects, we'll get to the point where you're not supposed to do that, but then we'll have helper scripts, and that's like 4 weeks down the line, more or less. That's also why I'm always typing like pwd and ls to make sure I'm where I think I am. So let me like whip up a text file here. And we can talk a bit about paths. So this absolute path command, it's probably doing almost exactly the same thing, but a little more specifically. I can use the OS standard library to get the absolute path to some other file. And that's really important because I could be running this Python program from wherever. So in fact, this part is a little funky, right? Depending on where I run this program from, this might not work. So this is how this stuff can, start to get tricky. But just for example purposes for today, I want to show this. So we can get an absolute path. And whether we get an absolute path or whether we type it out, once we have a path to our file, Python has a command called with that is kind of interesting that does a bunch of different stuff. And we can do it a couple ways. I'll do it since I went ahead and I did the hard work of getting the path. I'll do it this way. And let's see what we're complaining about here. Using open without explicitly specifying an encoding. That is okay. I guess I should have specified the text encoding, but there's some sort of default value and I doubt it will break. Hopefully I don't have to eat my words. So hello world, it's sunny, goodbye, which is what I had in my example text. So this with command is kind of great. In Python, it helps us do all sorts of things. This R is short for read, which is nice because it lets our program open a file, but we can make sure even if we do something silly here, it won't overwrite it. If we wanted to make changes, we can put write. You would have to read a bit more on kind of how to use this to do that, but that is the basic idea. The one thing I really skipped over was like exception handling with try and except. It's relatively straightforward. I would suggest just looking at it. I'll take just a minute now to look at it, and then we'll break and let me get back to you guys for what we're going to do the second part, because I realize that it's 3 o'clock. But before we wrap this, do folks have any questions? Okay. Cool. So this is the last bit, and then we'll break for a while. We've talked about programs. We've talked about errors. We've all seen errors. I'm putting some spaces in here for my own sanity. Basically, I think JavaScript has like try catch blocks. Python's try except else blocks are a bit better. I'll talk a bit about what this is for. Let's say you're writing a browser. We're going to write the successor to Google Chrome. If something goes wrong loading a web page, we don't want the whole browser program to crash and quit. So just as an example, there are all sorts of times when even if one part of our program goes wrong and throws an error, we don't want the whole program to crash. You can think of all sorts of safety critical programs where this is the case. So we have to design into our programming language and program runtime some way of dealing with errors. And obviously there are different kinds of errors, and some errors just are going to crash the whole thing. But that's this idea of a try catch block, where if we're doing something that we know might fail, and often this is talking to another program, talking to a computer over the internet, because if my browser tries to load a web page from Wikipedia and the Wikipedia server is down, I send an HTTP request and my browser is going to be waiting until the end of time for the response to come back. And so that's an easy way to break a program, right? Because we can't always control like the data that comes in or when it comes in. So our program has to interact with the world, and programs interact with each other. So we wrap it in a try catch block. Python calls it try, else, so on. An exception is the name basically for an error that is caught and handled somehow. The code we might think screw up goes into the try block. Except is where we specify if an error happens inside here, what should I do? If an error doesn't happen, if it all goes well, that's what the else block is for. Finally is the bit that we always run, no matter what. So let's run this and see what happens. So this is good, right? Our program didn't fail. I know there was an error, so on and so forth. Here's the one thing I want to mention, and the reason I did want to touch on this. Now we have to debug our program. Do I have any data from running the program on what went wrong? And the answer is
Squiggly line.
no, I do not.
Oh.
Oh, sorry. Go ahead, Frank.
I was just gonna guess the squiggly line.
The squiggle, well, yeah, absolutely right. With the edit of the squiggly line. But if I'm just looking at the output of the program, which is good because with the program running, and also sometimes VS Code is wrong. But in terms of like debugging, looking at what your editor is hinting at you is always good. Equally important. And also sometimes VS Code is wrong or just can't give us squigglies for everything. Again, like if we're talking to some other program, it's really hard to debug without data. I don't recommend it. You really need to get good data. And maybe I don't know what's going on. I could do this. I could do print created vars, print printed D, printed E. And now if I run this again, I can see how far I get before I fail. I can make breadcrumbs. And this, people use debuggers for this, and I think we will try to demo that. Some people love debuggers, and they are really powerful. I also just have always done tons of print statements or console logs. And so now this is great. Created vars, printed D. I didn't get to printed E. So now I've isolated which lines of code could be the source of my error. These two lines. That is a really good debugging tactic that you'll do all the time. What's even better would be to have the actual error message. And this is sort of the trap of try except blocks, is that our error message got swallowed. Our program gracefully handled the failure, but we don't have the information we need to debug it. And you can actually like define exceptions, and it's a little funky in Python. In JavaScript, it's a little bit easier because I believe with Python, like you have to I'm not sure how much information I get from here. And Python like has different kinds of exceptions. And I haven't dug into it too much, but so that's actually not bad. That there we actually got an error message, right? Exception as error, print error, unsupported operand types 4+ int and string. Honestly, in a lot of ways, the easiest thing sometimes is don't have the try catch block at all, run it, let it fail, and see the error message. Honestly, well, that's a different error message, which is the risk of modifying code on the fly. But I get rid of the exception. I get a line number where it failed, and I get that same type error. So now I know on line 9, there's a problem. I tried to add int and string together. So try catch blocks are great. Just be aware that the downside is you're not always getting a full error message. So when you're debugging, sometimes you might want to comment out your try catch block, or you can, in the except block, add an exception and print it out, which gives you some of that information. Folks have any questions before we break? Because I know this was a long one. All right, let's take 20. let me check in with Francisco and see what he wants to do. And we'll either do work time or figure out where to put the Pytest stuff today or tomorrow so that we can cover it. But let's take like a proper break and just reconvene in 20 minutes to figure out our next step. Sound good? Awesome. Thank you, everyone. I will see you all in 20.
Set a timer for 18 minutes.
Sounds
Oh my God. We, yeah, hold on a second.